split my presentation in half. I'm going to focus the first half on inland river response, the second on open water response, and then with that, talk about some response support that can assist making both of those types of responses come off. Initially, working in a river environment, it's real important that you choose the correct vessels to work. That's going to be a very important first part of the response, or whatever you're going to be doing. These are just an example, and everything I show you today are just examples. There's many types of manufacturers and types, but these types of boats are built for low freeboard, fairly high horsepower. They usually have twin 115, 150 horsepower range, and the idea is they can work in strong currents in fairly shallow water. Many times you really don't even have enough water to run shallow draft boats, so it's necessary to bring in even smaller boats. Let's see if I can see better on this side. Like these John boats here in the lower corner here, to actually get boom position. And what they've done in this case is they've got the boom position that's secured on this bank, and if we don't have enough water, we come back and use these little portable caps and winches, and they work very nice to pull the boom across and get the boom in position to meet the tactic that you're trying to acquire. And we're going to look at some actual booming strategies here in a little bit. But the other nice thing about these little caps and winches, that we're going to see a lot of river systems in Michigan that you don't always have good access. You may not have a boat launch available to you. So you can easily carry these things in. It's basically like carrying a chainsaw, and get in the position, get the boom in the water, and get it deployed, and not have to rely on vessels and launches and so forth. This is a kind of a typical boom. It's kind of a river boom. You see most of the responders you see, especially in the Michigan, you'll see this is a flexible type boom. It folds up in an accordion, fits in trailers real well, and deploys rather rapidly. The boom has different size flotations, and then below this there's a skirt. So you have a flotation, and then you'll have anywhere from typically a 6 to 12 inch skirt down in the water, and that's basically what diverts the contaminants that are in the water to an area that you want to try to get them to. There's different type strategies, single diversionary, cascade, and a chevron. I mean, these are kind of the three main. There's many different types. A single diversionary is what you're is very effective on a river system. So what you're trying to do, and I should mention that when you respond in a river spill, you're trying to get your boom in place prior to the contaminant coming downstream so you can collect it. It'll be a little different in open water. We'll talk about that. So here's an example. So where you have your boom is in place, this is your containment boom, a single diversionary. It's anchored out here. The contaminant, the oil is coming down here, and it's collecting in this area. And then this becomes your collection area. So you have, in this case, they show a vacuum truck, probably hooked to a skimmer here, and where you're doing your removal. Very dependent on what you need to pay very close attention to what the wind's doing. You want that boom configuration to work consistently, with the wind, so the wind is assisting you. So when you get out and do your assessment, you need, before you set your containment boom, you need to determine what the wind is doing and what the current's doing, and then that's what you work in tandem with your containment. This is kind of real life here. This is a nice little configuration because you have a diversion boom in place. And they've also took the time to put a protective boom along the shoreline. So this is kind of going into the final cleanup up here. You see the responders, but the shoreline was protected. It didn't get impacted by oil. So once the oil is removed, you can remove the boom, and pretty much you have an oil-free shoreline. This is a chevron configuration. So you have a boom on each side. You create a V. Sometimes you have a closed V. In this case, it's left open, which allows for boat traffic to come and go. It's secured to shore. Doesn't matter what the wind's doing, as the current brings it down, the oil's either going to come to this side or this side, and then you can see the recovery going on here, and the same thing would be going on here. So real effective if you have the time. Works a little easier to deploy in narrow channels. And then this gives you an example of the oil. This is, there's a perfect configuration here. You can see a nice line. The oil's being diverted. A lot of oil still coming down, and you got a skimmer vessel working here, and then back in here you'd have shoreline collection going on as well. Here they didn't take the time though to put a protective boom along the shoreline, so you see you have a very heavy, like riprap material. So once the oil's removed, you're probably going to go in there and you're going to be doing a major excavation, damaging the bank, and so forth. So, and sometimes you don't have the time, and sometimes you don't have enough resources. But anytime you can, I really encourage that secondary boom, and it's very simple to set. It's probably one of the easiest sets there is. Real quick, we see a lot of this type of configuration with these little U's, little horseshoes. Maybe they're hoping for good luck, but they're extremely ineffective. And you're tying up a resource, you're tying up time. What happens is the contaminant comes down, you can see the entrapment that's going on. It just continues going downstream. And the other thing with this, if you do collect anything in here, then how do you recover it? It's all out in the middle of the channel. These are perfect configurations. You see nice straight lines. This is a real nice configuration. They're diverting the oil away from this little sensitive area here, being very well protected. The oil's coming down the channel, and here you have a major collection going on. This is probably towards the tail end of that cleanup, and initially there was probably as much or more oil in that area like we saw in that one slide. Same idea here. You see the nice straight line diverting it into an area, and then they've got secondary booms in place downstream, but pretty much no sign of any hydrocarbon outside of the boom area. This is what a boom failure looks like when you're trying to put a boom straight across against a strong current, doing absolutely nothing. The skirt's just laying at the surface of the water and just allowing the oil to travel underneath, just as it shows in this slide. So there's a trained technique to doing this type of work, and it's important that the responders that you're relying on have that capability. There's a lot of responders out there that have this equipment, but maybe not have mastered the technique of deploying it. Just a real general angle for when you're dealing with strong currents. You can see up in here in this range here, low knots and slow flow, you can pretty much do what you want. As you go into higher flows, and you got to tighten your angles up, and that angle being this right here. This is your boom, and this is the bank. So if you're dealing with maybe a knot, maybe less than a knot, you can pretty much have in the area of, a 50, 60 degree opening, pretty well have it open. But when you get down into 2 knots or greater, that angle is probably going to be somewhere around 20 degrees or less. Technology that came out of Sweden, it's actually been here for a while now, but it's very effective in working in fast water. One of the real difficulties of setting boom in fast currents is anchoring it. So this is a technology they call the boom vane. It's designed, it works best in about 2 knots to 5 knots. If it's under 2 knots, it doesn't work real good. And if it's over 5 knots, then the unit will start to porpoise. But what you have is a vane system. This is the boom vane that you just saw. What you just saw was that flotation. This has a vane system on it that works in tandem with the current. And when you deploy it, it takes your boom, you have your boom attached. I'm going to show you a picture of a boom in place. And then you have the boom at the upstream end of the booming at the upstream end of your boom, and you set it, you do it on a pulley system, and it carries the boom out and sets it and holds itself in place against the current. So it's a real neat technology and real simple. And this kind of shows you just the actual deployment of it. You get the vane in place here, you get it secured, and then this shows the vane being flying out in position and hold the boom. And then if you want to bring it back in, if you have to adjust it for debris or whatever, you just trip a pulley system and it'll come back into shore. And that's what a boom vane looks like. This is the actual boom vane right here. And it's holding this boom. We just talked about single diversionary boom, and it's upstream. So this is your flow coming down like this, and can go right into your diversion boom for collection. This is a same idea that just took it a little bit further, and you have your boom vane is here, which is holding the boom in place, and then they have the second unit that's used for working in fast water. Because a lot of times it's real difficult to do recovery with a skimmer in this fast current. So the actual skimmer is inside of this little unit here. It's like a floating lagoon, actually. It protects it, and then it diverts everything into this unit here, and then the collection takes place here. And then you can put any type of skimmer you want in there. To give you a real good idea, and talk a little bit more about drum skimmers, but they're probably I'd say probably one of the most efficient ways of recovering oil. They're very portable. They come in many different sizes. So when you see that boom where we were collecting or diverting the oil into for collection, then you're probably going to have something like this. There could be different type skimmers, but it's simply a drum that rotates, collects the oil, and as the oil comes out over the drum, there's a Teflon wiper here that scrapes the oil off, goes into these reservoirs, and then you can see a hose coming from each one of these, which is connected to a vacuum truck. So efficiency of recovering the oil is critical, especially in the early part, because you may not have a lot of storage. Initially, you're ramping up, you're bringing in portable tanks, frat tanks, but in the early part of the response, you may only have one frat tank available to you, which is only going to hold roughly 20,000 gallons, and you can, if you're not managing what you're doing in the recovery, you can quickly fill that tank up, and then you're standing down. You're waiting for more storage to come in. So the management of that is real critical. I'm going to just kind of go through these real quick, but just to give you an idea, there's a whole lot of different technology out there. These are disc skimmers. This is what's called a brush skimmer. Same idea. The oil collects on these brushes. As it goes down through the water at the surface, comes up and collected. Same idea. These are smaller brush skimmers. And this is a weir skimmer. Weir skimmers, if you have a lot of oil, they make sense. Wow, already? I'm gonna give you 5 extra minutes. Okay. I'm gonna jump ahead a little bit. So one of the difficulties that you can run into in a river cleanup is you can see the fast water, but also huge buildups of debris. I mean, it's very common in river systems. And typically where the debris is or where the natural collection areas are. So that becomes a problem in itself, where all this oil debris has to be removed, treated like a solid waste. Then you can come back behind that and do your recovery of your oil. This is an ice response. Same idea. This was a tug that capsized. As fuel came to the surface. We talked about it earlier today. The ice actually acted like a containment. In this particular case, we were able to get a boom in as well. And then this is just a little drum skimmer recovering that diesel fuel that's coming from the tug. Jumping into open water, now we need to, now your equipment's going to start getting bigger to be able to handle heavy seas if needed. Protecting areas are going to be large areas, and large areas are going to require large amounts of boom. This is down at Deepwater Horizon, where we were preparing for the oil that was shifting over from the currents, and it was lots of thousands of feet were loaded on vessels like these, and then shifted to areas. And you can see up here where from the boom it was shifted to these small vessels, and they were bringing it to shore, where the personnel were getting it prepared for protective booming. This is larger type boom that may come into play. This is all it's inflatable boom. And this is a shore seal boom, so you have a major spill, it starts impacting the shorelines. Now you may want to try to keep it, you do want to try to get it from migrating back out, and to get a good seal, you deploy this type of boom. This type of boom where you have an air chamber and you fill the bottom two chambers with water to ballast them down so they seal and they follow the contour of the shoreline. Large disc skimmer that can work offshore, same as what we talked about, the little ones. These are the Dutch Cossack skimming arms. During the one advantage to the Deepwater Horizon response was a lot of the resources came in that were currently here, never really used in an actual spill. We had an opportunity to use them and see what was effective and what wasn't. The Dutch skimming arms were quite effective. They're a skimming arm that are placed alongside a vessel, and then you aggressively go after. So we're talking about this oil up here that may be shifting back and forth and back and forth. Well, you don't want to be waiting for it to get to you. You want to go get it. You want to be very aggressive in open water recovery, and this is one method of doing that. Some of the things that you can see, this is the oil that's trapped in these skimmer arms, so it was collecting pretty large amounts. One of the difficulties that was recovering this oil is because a lot of it had been hit by dispersants, so a lot of your traditional skimmers didn't work real well on it. It kind of didn't adhere well to the brushes and to the drums. And this is just another version where we scaled back where they were a little more portable and they're in containers and faster to deploy. This is was extremely effective in Deepwater Horizon, and I could see it being very effective up here. These are the Milky Ocean Buster skimmers. They come in three different sizes. Very simple concept. I got a better shot. Basically, you tow them. As you're towing them, you go through a slick. The oil comes up into the boom area, up into the actual skimmer area, and there's at this little choke point right here, separates the debris, and then the oil ends up in this pocket right here. This pocket right here is about 45 feet deep, and it acts like an oil water separator. So as the oil is coming up through this system right here, this point right here chokes off, prevents it from big debris getting in there. It comes in here, and the oil comes to the surface, and the water continually goes out the bottom. The bottom is open, so you can, if there's thin ribbons of oil, it'll collect that heavy. It doesn't really matter. It's proved to be very effective on Deepwater Horizon. And then what had to be also take place though is offloading stations had to be set up so that this oil could be removed. So we had vessels that would come in. These are portable storage tanks. The oil would be pumped out of the skimmer, put in these tanks, and continue on its way to continue skimming. Another technology is the Markle belt skimmer, quite portable. Same idea, only they have an incline belt that comes up here, and you lower it down into the oil, clutch the oil comes up, it goes through a mechanism that squeezes the oil out. It has its own storage tank, it has a 1,000-gallon storage tank, and you can collect the oil. It separates the oil quite well. They're trailerable, they're only 28 foot long, they can be towed, and then you can also open them up and add additional boom to them. The recovery rates are roughly, ideal conditions, 427 barrels per hour. And this is the skimmer working here in tandem with a boom vane. You see another skimmer operation. And these are real effective ways to do open water skimming, because what I would envision is you're going to have ribbons of oil, windrolls of oil, and basically you're running your skimmers back and forth, just like mowing the grass, collecting the oil, and you're being directed from the air. Talk real quick about that. This is a regulation. Plant holders have to, either plant holders have to have the capability or they have to have a contractor that has the capability that can do aerial observation directing skimmer operations. So now you've got these skimmers out working and you have a real-time person in a plane, you have a command vessel in the water, he's sending directives down, GPS coordinates, where the oil's at, and they're dispatching real-time skimmers out to the oil, where the oil slicks are for rapid recovery. It's a lot better than many times they do an overflight, bring the information back, then they decipher the information and determine where they want assets. This is all done right now at the time. Okay, let's see, I think this is wrapping up. During Deepwater Horizon, over 3,000 vessels of opportunity were utilized, and it'll be the same thing up here. There'll be a very critical asset to support any type of operation that's going to go on. These are just some smaller versions, but you can see that things were adapted. You get into more remote areas, you still have certain needs that are out there. I think it's real important. You can move a lot of cargo, a lot of response equipment, but via air cargo. But it's important that you have a plan in place. You have airports that have been identified, what size airplanes they can take, especially when you start talking cargo, C-130s and larger. And also, ideally, if a company has their own plane to move personnel, it certainly helps things. So, sorry, that was real fast. I do apologize, but it's just not enough time to deliver that kind of information. Thank you.